Greetings, Artie from Artifact Electronics. Today we're going to talk about this wonderful invention called a GFI outlet. GFI stands for ground fault interrupter. At least that's what it used to be called, and then it got called a GFCI outlet, a ground fault circuit interrupter, but the two pretty much mean the same. And what these outlets do is they strive to save your life. The best example is that if you're sitting in the bathtub and you're dumb enough to have a hairdryer plugged into an outlet, and that thing slips from your hands and falls into your bath water, you're probably dead. If you did not have it plugged into a GFI outlet. Now, if you did have it in a GFI outlet, the GFI outlet would trip an internal fuse on it, and life would go on. So, first of all, how do these things work in real life? And that is, they do have test buttons on them, which is very important. You got to make sure to test these things. And test operation is pretty easy. There's a black button and a red button on here, and the black button is labeled test. So when you hit the black button, you hear a loud click, and you see the small LED on the bottom right go off, which you can't really see with backlighting. But anyway, when that trips, then it's operating correctly, but the outlet is non-functional right now. But all you need to do is press the red reset button, and we're back in business again. So just to see that, let me turn off the other light and see if we can get that LED onto the video. So you can see the little green spot there. I press the test button and it goes off. I press the red button to reset it again, and it flashes up in red briefly and turns back to green, and we're back in business with this outlet. It's very important not to confuse a GFI outlet with an actual circuit breaker hopefully found in your house, which makes sure that each sub-circuit in your house doesn't draw more power than the wires in the wall can supply. Because if you do, there is a risk of the wires in the wall catching fire, thus your whole house catching fire, and lots of damage to property and bodies can result. So if we look at the basic hierarchy of what it looks like, let's say an outlet. It's really not a good picture, but let's just say an outlet looks like this, and then we got another one, and then we got a whole bunch of other ones. And then we basically got a trunk wire here. Let's call this one, well, it connects, of course. And there's also a ground wire going, but I'm going to leave that out for brevity's sake. But no big mystery, this is what it looks like. So your chain of outlets can be one outlet or several outlets. And we got hot and neutral over here. And this runs through the walls and ends up in your wall panel. And these two lines will go to a breaker in the wall panel. And the wall panel has many more breakers, and the other end of the wall panels goes out to your input, and your input comes from the street wherever power is fed to your house. Now we all know that if this chain or this block of outlets, let's say we have a 15 amp breaker over here, that if the sum of all the currents running through each of these outlets exceeds 15 amps, then the breaker will trip, and thus reducing or eliminating the danger of these wires, which are usually rated at what the corresponding breaker is rated at, from burning up and causing all sorts of havoc. So again, it's interesting to note that a GFI does not replace a breaker in your breaker panel, but rather supplements it. So now let's add a GFI outlet to this hierarchy. A GFI outlet does have two sets of terminals on it, unlike the ones where regular outlets have a single set of terminals, and of course the earth ground has been eliminated here just for purposes of demonstration. But the way it works is, let's say we cut the connection here, and what we do is we run the wires coming from the chain of regular outlets to the GFI outlet. Now the GFI outlet, again, has a second. These are the so-called load terminals on the GFI outlet. And what that means is the GFI outlet doesn't just protect itself, but it protects everything that is connected to the load terminals on it. And to make this a little bit more obvious, even though it doesn't topologically match this exactly, but then we have a little box here that performs the GFI function. And that box is hooked up to the incoming power. This is getting really messy. Sorry. So that's the load terminals on the GFI, and then there's the regular AC terminals. It looks just like a regular outlet, but and regular double outlets will usually have a pair of terminals on it, but those terminals are internally connected. Whereas on a GFI, the two sets of terminals are not internally connected, and they should be clearly labeled load or AC or input. So with this thing in mind, now what we have is we can clearly see that the GFI is supplemental to the breaker itself, and the way it works is that everything that happens on these outlets, including the GFI outlet itself, is it monitors for current leakage. What happens here is generally in an outlet, if you monitor the incoming current and the outgoing current on the two AC lines, it should be equal. Because if it's not equal, then the current is leaking outside of this path somewhere, and that path may be somebody sitting in a bathtub or standing in a bathtub and throwing a hairdryer in there. So there's water here, and if you throw the hairdryer in it, you will create an alternate path to ground, and thus you will start leaching current through here. Well, when you leach current through here, the GFI outlet will detect that there is a current imbalance between the two lines, and if that current balance, which currently in the US is specified to be 5 milliamps, if that current imbalance exceeds 5 milliamps, this GFI fuse in here will trip, and it will cut off power to all of the outlets, hopefully saving your life. But as you can see, that really is not something that the regular fuse could take care of, because the regular fuse doesn't care about whether the current coming in here is exactly the equivalent as going out. It just worries about what is the entire current load and acts accordingly on that. Whereas this one works on the imbalance, which has the effect of detecting something external leeching current off, and if that external thing happens to be a person or a pet or anything else that is creating a fault, a ground fault, then this will shut off and immediately remove AC power to all of these, and that's how a GFI works. Just a little bit of clarification here, which may make this even less understandable. No, the line that's going from this outlet to the GFI box, that's actually, those are two wires, of course. These are the wires that are actually supplying the AC current that's coming from your outlet, and the fuse is contained in here. It's a resettable fuse, of course, driven by a solenoid, but so when this, under normal circumstances, your AC power is normally supplied to the subchain here, but when the GFI detects the circuit imbalance, it cuts off right here and thus cuts off these two wires. You see that there no longer is any direct connection between this subnet and the breaker box. Second of all, the victim here electrically basically looks like this. It's a resistor. You are a resistor, and by introducing a resistor from hot to ground, you're going to leach current from it, and that's what alerts this part that there's an imbalance, and it'll cut off. As far as the street connection is concerned, some of you may want to point out that is not supplying 110 volts in the US, but rather it gets more complicated because we have 220 volt outlets, and that comes from a three-phase supply, and so there's a whole bunch of other stuff happening on this side where this is being connected to the breaker box, and but that is irrelevant for our today's discussion. So there you have it. Our discussions would be incomplete if I didn't at least attempt to show you what these things look like, the innards look like in real life. So I took the picture of someone who can draw a lot better than me that showed the general outline, what the inside of a GFI looks like. And then I took a GFI itself that I removed from the wall because it had been in there for a really long time. And it's discolored, and over here it's discolored. Let's see. So actually I said before that one set of inputs is labeled load and the other one AC. It's actually labeled line, but you know what I mean, right? Anyway, so the discoloration here was kind of interesting, but briefly looking at this is, here's your line input, and your line input under normal circumstances just runs straight through. There's an internal electromechanical circuit breaker here that, when it's normally operating, has these switches closed, and we just got AC flowing through here. And it does have a rectifier bridge over here because that's what supplies the coil or the solenoid for the electromechanical fuse, as well as the comparator. It's an op-amp comparator that when it senses the prescribed current imbalance, fires off an SCR that energizes the solenoid, which then interrupts AC supply, the AC being supplied through here to the load terminals. And at that point you need to reset it, which is probably another line. You ground something that's coming out of the op-amp, or that would reset the whole circuit. Also, I should add that if the GFI condition persists, you can reset this thing all you want. It will keep tripping on you, because the minute you hit reset, this thing gets powered up, it will sense the current imbalance and just trip the whole thing again. Now, so looking back, Yeah, when I took this apart, unfortunately a bunch of pieces fell out of the back end. There were the levers that are hooked up to the solenoid, but I puzzled over it for a while, but I couldn't really put them in the right way. But again, for our discussion, since we're just doing a very quick view of this thing, here's the discolored area we saw on the other side of this case, and that's because this is the rectifier bridge, which is always energized. Whether this thing is tripped or not, as long as AC is coming in, this rectifier, this guy over here, is energized in order to power the comparator circuit, as well as, if necessary, if we're in a tripped state, to keep this solenoid energized so we stay in the tripped state. Further down, we have these two coils here sandwiched together, and these are the current sensing coils, which run into the op-amp over here that does the comparison, and if necessary fires the SCR that then fires off this solenoid. When the plunger on this solenoid comes out here, it turns these levers, and I'm sure they were installed correctly originally, and what these levers do is they separate these two contacts. That's a great way of showing it. Let's try that again. Separates, pushing these contacts aside, and thus interrupting the AC flow to its own outlets, as well as any outlets that are connected to the load terminals. And that's one of these things looks like. GFI outlets are required by building codes to be installed in moisture-rich environments, such as bathrooms, kitchens, or maybe the indoor pool room you have. And just to prevent the kind of accidents that could result from a hairdryer falling into your bath water, or maybe your pool is lit and one of the lights in the pool malfunctions and water goes into it and tries to fry the whole party in it. But the idea is that these have been improved over time, but especially the earlier revisions gave a lot of false positives where they would just trip for the oddest reasons, especially if you had one installed outside where there's a lot of moisture swing and just odd things are happening. This has gotten a whole lot better, and usually that condition doesn't persist. It's a momentary condition that'll trip it, and of course if it's a false positive, then you just go back and reset it, and it comes back into operation again. But this situation can also bring up a nice logical problem, which I ran into in my own house. And of course I thought that this problem was completely unique to myself and nobody in the world had ever experienced it. And once I actually solved the problem, a few days later I spoke to somebody who was pretty much, as I'm telling him the story, he's echoing my words, and before I can even get out the punchline, he's saying the punchline. So that led me to believe that this is actually something that can commonly happen, and this is what actually was the main impetus for me to make this video, because if I had this problem, it obviously seems that a lot of other people may have had or will have this problem too. So here's what happened to me. I have a single solitary outlet somewhere in the deep recesses of my basement. Call it this guy. And what I generally use it for is I have lights that I can plug in there. It's in a dark corner. Yeah, if I'm looking for something, then I can actually see the area that I'm searching. And this outlet I was plugging in, I think it was a handheld LED work light or something, and one day I plugged in the work light and the work light didn't come on. Of course, tested the work light in other outlets and they were working, but this outlet itself was dead. So I run to the fuse box, to the breaker box, and check all of the fuses, and they were all good. And I said, well, you know, maybe they're misbehaving, and I go ahead and manually trip and reset all of them, causing havoc, major havoc everywhere in the house because everything reset. It still didn't fix the outlet. So that was a mystery to me. And so we're in the basement here. And the assumption is that this is, of course, connected to the breaker panel. But no, that wasn't it. It took me quite some time. I finally gave up on this outlet. I just couldn't figure out why it wasn't working. And I started running extension cords to power my work light to light up that area. But what it turned out it was, so let's draw a line here, and this is a physical line, not a conceptual line. And this is the main floor. And what happened here was, on the main floor, I have a guest bathroom. And in the guest bathroom, there was a GFI outlet. And of course, the GFI outlet is the one connected to the panel. But what my mistake was, or what I couldn't really figure out, was that this connection didn't exist, but rather this connected to the load terminals on the GFI outlet in the bathroom. Now but the work light I had been plugging into here, for some reason, tripped the GFI. And since it tripped the GFI, this outlet was dead. And no matter how many fuses I reset, breakers I reset on this, wouldn't fix the problem. So the big problem to ask is, well, why didn't you realize that this outlet was dead? I mean, even if you didn't realize that this had anything to do with this, you should have realized that this outlet was dead, reset it, and then that would have brought this one back to life, which is what eventually happened. But the kicker here was that this is in a guest bathroom, and I guess guests generally don't use the outlet in a bathroom very often. They do their business, they use the sink, but they don't use this outlet. And what had happened to me was I was trying to fix a light fixture in this bathroom on the main floor. And of course, in order to do that, I had actually found the fuse for the light fixture and turned that fuse off. And so it was dark in that bathroom. And so I brought my work light up and plugged it into here, and it didn't work. At which point, I hear, weird music playing in my head going, well, wait a minute, and physically these two outlets, even though on different floors, were like right above and below each other. So I just hit the reset button on this GFI, the work light came on, and I finished my work in the bathroom. But then the really big light bulb came up, and I said, what if? I ran into the basement with the work light, plugged it into here, and of course, it was working now. The moral of the story is what all of this boils down to is that we have restrictions, or we have directives to use GFIs in moisture-laden environments. But there's no directive that says that your fuse box and or your house wiring has to be fully documented, or even if it is fully documented, which it probably should be in the blueprint somewhere, but there's no requirement to have user-readable diagrams of those. If I had a diagram, if I knew that somebody came in and just kind of figured I can wire this to this and then we'll have power and I don't have to run more wire in the wall, well, I would have found the problem immediately. But my main breaker box isn't even labeled properly. I mean, they started out with good intentions, but then they kind of gave up in the middle, and I've done a pass of going over it and trying to label things and so on. But The main problem, so you can't really blame the GFI for that, because if you knew that this was connected to the GFI, you would have found the problem immediately. Nonetheless, with people not properly documenting how outlets are wired, or anything else is wired for that matter, I guess what it boils down to, if you ever have a dead outlet and you can't find a trip fuse in your breaker box, go through every single GFI outlet in your house and press the reset button. That will probably fix it for you. So here's what my main breaker panel looks like, and you can see that the neat labels I've put in later on. I found out the hard way which was which, but the handwritten stuff is the way it came. And for instance, if you look at this, lights with a big arrow going down. Yeah, okay, we know that it's lights, but that's a shitload of lights, because we got one there, and then we got another one there, and another one there, and you need to go through these, or I need to go through these and really figure out which is which. Now for that, generally you can use a signal tracer and actually really figure out, well, what outlets are interconnected and which fuse they're connected to and all that. The problem with that is this, I mean, in my case, this is the main panel, and if you look up there, you'll see a whole bunch of 15 or 20 amp wires, the light colored ones running into the house. There's a fat black one on the left, which is most likely the 240 volt that goes to heavy appliances such as washers and dryers. And there is a fat gray one in the middle that in this case is a 300 amp main supply that goes to the street. There are no breakers I can use to disconnect that main line from this breaker panel. The only way to do that would be to get an electrician out here who goes to the street and essentially disconnects the live circuit in the box where the connection is in the street, disconnecting everything, and then I'd have to go through a dark house. Well, that's what flashlights are for, but that's the only way I could use a signal tracer to create a map of exactly what is connected where, while that guy's waiting outside, and then go back up and tell him, all right, buddy, come back and hook it up again. So, you know, that is, I mean, I could do that, but no, I'm not going to do that. The only other way, of course, is to turn each fuse off and then find out what it actually turned off. But the problem with that is, again, it will not tell you whether a GFI is on top, is at the very beginning of a subcircuit, or even worse than that, in the middle of a subcircuit. The only way you could do that is to actually rip your walls open and see where all the wires go to. So the piece of advice I gave you last is, if you got a dead outlet, check all of the GFI outlets in your house first before going bananas, like I was about to. I was really inspired by this label here. I mean, I got into the house and I said, wow, this thing's got a Mirco installed. So where is the Mirco? Is it like in the attic, or is it in the garage, or what is a Mirco? Anyway, I was being dense. I think what they meant to say, I think that's supposed to say micro, translated into microwave. But it did give me a few minutes of amusement. Well, even if you don't have the same problem with dead outlets, I think you should go through your house and test every single one of your GFI outlets by hitting the test button, listening for a loud click, and then pressing the reset button right afterwards. So thanks for watching. Thanks for thumbs and subscriptions. And we'll see you later.